So first concept is work done. In this work done, there are three subtopics, that is work done by constant force, second one is work done by variable force, third one is meant. So our first concept is work done by constant force so work done is represented by W, and this constant force we write it here as small f. Okay, so if we are finding work done by gravity, we have to write it as work done by gravitational force or gravity should be written as WG, right? So and work done by a force WF is equal to F dot S. Work done by force is F dot S, where F is the applied force.
Sir, I can't hear you, sir.
You can't hear me? No.
No, sir, it's clear. Sir.
Can you hear me now?
Yes, sir.
Yeah, nice. So F is applied force, S is the displacement. Actually, F is not applied force. F is the force and S is the displacement. Okay, nice. So F dot S. So I think you know this as dot product. So
Yes, sir.
yeah, nice. So what is A dot B?
AB cos theta.
Yeah, nice. Mod A mod B cos theta. Okay. So A is the vector, while what mod A is?
Magnitude of A vector.
Okay. In the same way, B, theta is angle between
Vector A and vector B. Sir.
very nice. Okay. So this F dot S can be written as mod f into mod s cos theta. Okay. So is so these are the two important formulas you have to keep in mind. Then if you look at this formula can be written as wf is equal to mod f cos theta into mod s, where mod s is magnitude of displacement, mod f cos theta is direction of force in the direction of displacement. So let's say this is an object of mass m, and so force f acts on this mass. Initial position of this mass is initial at point A, and due to this force, which makes an angle theta with horizontal, due to this force F, this block which is of mass m, which is at point A, moves to point B. So here we have to find work done by the force F. So this can be written as F cos theta can be written as force in the direction of magnitude of force in the direction of displacement into displacement. So this is force F. So the component of force along the horizontal is, so we have to make a small triangle here. This is 90 degrees. So since this is theta, this component is F cos theta. So force in this direction is, in the direction of displacement is F cos theta. So displacement vector is from A to B. So this is the value of displacement, this is force. Now there are three special conditions in this which you have to remember. First condition is when theta is equal to 0 degrees. So here when this theta is equal to 0 degrees, F and S are in same direction. Both are in same direction. So when both are in same direction, cos theta. So here when theta is 0, cos 0 is 1. So this is the maximum value of cos. So if we substitute 0 here, we get mod f into mod s. So this is the maximum value of work done in this case, which is mod f into mod s. Now, second case is theta equal to 90 degrees. When theta is 90 degrees, force and displacement are, and theta is 90 degrees, force and displacement are perpendicular. So work done is mod f into mod s, and we have to substitute 90 here. We get work done as mod f into mod s into 0, which is equal to 0. So this is a very important condition. When the force vector and displacement vector or velocity vector are perpendicular to each other, work done by force is 0. So guys, do you know circular motion? Is circular motion completed? Hello?
No,
Sir-
sir.
No, sir.
No, fine, okay. Next. Third case is when theta is equal to 180 degrees. So when theta is 180 degrees, okay, force and displacement are in opposite directions. So force is in this direction, displacement is in this direction, force is in this direction. So work done is equal to, we know that mod f into mod s cos theta. So if you substitute theta as 180 here, we get work done as cos 180 degrees. So what is cos 180?
-1, sir.
-1, sir.
So we get work done as minus mod f into mod s, which is the minimum value. Minimum value of work done. So important points to remember here are, first one, work done by a force is f dot s. Second one, work done by a force is mod f into mod s into cos theta. Third one is when theta is equal to 0 degrees, work done is maximum. When the angle between force vector and displacement vector are perpendicular, work done by force is 0. When theta is 180 degrees, the work done is,
Opposite.
yeah, it's minimum. Okay, and force and displacement vector are perpendicular to, sorry, opposite to each other. Now look here. So what is range of cos theta?
-1 to +1, sir.
-1 to +1. So cos theta has positive values and negative values, right? So work done is mod f into mod s cos theta. So when theta is in between 0 to 90, work done is positive or negative?
Positive, sir.
Yeah, nice. It's positive. When it's in between 90 degrees, so it's positive because if we substitute any value between 0 and 90 in cos theta is positive and magnitude are always positive, so we get work done as positive. Next, so when the theta is in between 90 and 180 degrees, work done is
Negative, sir.
nice. So if you substitute a value between 90 to 180 in cos theta, we get a negative value. So it's negative. When theta is in between 180 and 270, it's negative. Okay. So you know all silver teacups, right?
Yes, sir. Yes, sir.
This is all silver tea cups. So this is 0. This here, this line starts at 0. This is 90. This is 180. This is 270. Now here cos is positive. In silver, cos is negative. In tea, cos is negative. In cups, cos is
Positive, sir.
Positive.
yeah, nice. So when theta is in between 270 degrees and 360 degrees, that is 0 can be written as 360. Okay. Work done is positive. Okay. Nice. Next. So displacement. So what is displacement?
The smallest distance covered by the object.
Very good. Okay. So displacement is a vector or scalar?
Vector.
Vector, sir.
Vector.
Displacement is a vector. Second point. So displacement is the smallest distance between initial position and final. See, this definition is perfect. There is no problem with this definition, but you have to remember this one also with this, that is displacement is final position vector minus initial position vector. Okay. So final position vector is nothing but final position of the object. Initial position vector is nothing but initial position of the object. Nice. Now
Join
first question. So question is, a body is raised to a height h from the surface of the earth what is the work done by applied force? By the so option A 0, option B mgh, option G minus mgh, option D none.
0, sir.
MGH, sir.
MGH, sir.
Yeah, nice. It's mgh. So see here I indicate mass of the body. A body of mass m. So this is the body. Mass of this body is m. Now can you tell me what are the forces acting on this body?
Neutral, sir.
Gravitational force and normal force.
So this body is not on the ground. This body is actually moving upwards. So one force is applied force, right? Another force is mg in downward direction. So this body is taken from, let's say, point A to another point B, which is at a height h. So this distance is h. So here what we have to find? We have to find work done by force F, right? So work done by force is nothing but force vector dot displacement vector. So here what is displacement vector?
H.
The h is magnitude vector. Just see, important, very important point. So what is a vector?
Direction
As
and magnitude.
magnitude and direction.
Yeah. So you have to write vector as magnitude into direction, right? So when I ask you displacement vector, you have to say it as magnitude of displacement vector into direction of displacement vector, right? Now look here. What is this direction? Unit vector representing this direction.
J cap.
Wonderful. This direction.
I cap.
Cap, sir.
Wonderful. So body is moving from A to B, right? So this so here magnitude of displacement is h. What is the direction?
H J cap.
J cap, sir.
Yeah, very nice. So you have to write it as hj. Now what is force vector? See, magnitude of force is how much? F. What is the direction of force?
J cap.
J cap.
So force vector is F into Fj. Is it clear?
Yes, sir.
So substitute force vector F as Fj, displacement vector as Hj. Is it clear? So we get Fh into J dot J. What is J dot J?
1, sir.
1, sir.
One. So what is the work done by the applied force?
MGH.
Fh, right? Now here we got Fh, but Fh is not there in the option. So we have to, what I have to do is, so can you tell me here what is the acceleration?
0, sir.
Why?
Because the body is moving towards the upward.
It's in constant force, sir.
So see here we have to take acceleration as 0. Why? Because here the body moves slowly. Okay. So velocity is almost 0. Is it clear? So see, we are taking this body from A to B. So here initial velocity is 0, final velocity is also
0.
0. Okay, that's why we have to take acceleration as 0. Now we have to apply, so here we have to apply Newton's second law. What is Newton's second law?
F equal to MA.
Summation of F net is equal to MA, sir.
Wonderful. F net is, remember, always you have to say Newton's second law as F net is equal to MA. So what is F net?
F minus.
So F net is net force, right?
Yes, sir.
So net force is sum of all the forces. So in our case, this is the free body diagram. Is it okay if I draw it here, or you want in separate pairs?
It's okay, sir.
So look here. Here, what is F net? So we have two forces. One is F vector, and another one is mg. So weight vector, right? So now can you tell me what is applied force vector? Is
Fj cap.
Fj. Fj. What is weight vector?
Mg minus mg.
Minus mg j cap.
J cap.
Minus mg j cap, right? So we know that F net is equal to ma and acceleration is 0. If you substitute a as 0 here, we get F net as 0. So what is F net? F plus W is equal to 0. So F is Fj cap, W is minus mgj cap is equal to 0. From this we get F as mg. So if we substitute this mg here, we get work done by applied force as mgh. So option B is correct. Next. So if I write by gravitational force, what is the answer?
Minus mgh.
So work done by gravitational force is Wg. is equal to gravitational force is the weight. So weight vector dot displacement vector. So weight vector is minus mg j cap. So we substitute minus mg j cap here. Dot displacement vector is hj. So j dot j is 1. We get answer as minus mgh. So we can solve this problem like this, or we can write work done by gravitational force as W dot S, where W dot S is magnitude of weight into magnitude of displacement into cos theta. So theta is angle between weight vector and displacement vector. So weight vector is in downward direction. Displacement vector is in upward direction, right? This is displacement vector. So what is angle between weight vector and displacement vector?
180.
180 degree.
180 degree.
Yeah, nice. So magnitude of weight is mg into magnitude of displacement is h. Cos theta is 180. Cos 180 is minus 1. We get minus mg h. Okay, nice. So if you want to note it down, just note it down. Next question is, a body is displaced from 2i plus 4j minus 6k to 6i minus 4j plus 2k under a constant force F is equal to 2i plus 3j minus k Newton. Now find the work done by the force. So option A, 10 joule. Option B, 20 joule. Option C, 24 joule. Option D, minus 20. Take 2 minutes to solve this problem. Okay. Anyone got the answer?
So minus 24.
Very good. Answer is minus 20. Fine. So here you can see that the force is a constant force, right? And they are asking to find work done by this constant force, right? So we have to use work done is equal to, we have to use this formula F dot S. But displacement vector is final position vector minus initial position vector. So final position vector minus initial position vector. So final position vector is 6i minus 4j plus 2k. Initial position vector is 2i plus 4j minus 6k. So if we substitute this initial position vector and final position vector in this displacement formula, we get 6i minus 4j plus 2k minus 2i plus 4j minus 6k. 6 minus 2 is 4, minus 4 minus 4 is minus 8j. 4 minus 4 is minus 8j. This is plus 8k. So we have displacement vector, we have force vector as 2i plus 3j minus k. So work done is F dot S. So 2i plus 3j minus k dot displacement vector is 4a minus 8j plus 8k. So if we do dot product, we get 8i dot I. So first we have to multiply 2i and 4i. So 2 into 4 I dot I. Then we have to multiply. See, so 2 into 4 8. 2 into 4 8. Then 3 into 8, 3 into minus 8 minus 24. 4 8. 3 into minus 8 minus 24. Then minus 1 into 8.
Hello, sir.
Yeah, hello.
Sir, எனக்கு புரியல sir இது.
You didn't get it, right?
Sir, இந்த ஸ்டெப் எனக்கு புரியல sir சுத்தமா.
Okay, okay. Look here. This is dot product. Okay. So see, A vector is AXI plus AYJ. B vector is BXI plus BYJ. So we have to find A dot B. So substitute A as AXI plus AYJ dot B as BXI plus BYJ. So here we have to do normal multiplication. First we have to multiply AXI with BXI. Okay. So when we multiply AXI with BXI, we get AX into BX I dot I. Clear? Then we have to multiply ax and axi and byj. So we get plus ax into by. We have to write it as I dot j. Then we have to multiply ayj and bxi. So plus ay bx into j dot I. Then we have to multiply this one with this one. So then we get ax by into j dot j. So I dot I is,
Sir, that is AY, sir.
hello, I didn't get you. What?
So that is AY, BY, J cap J, sir.
Where is it?
In
Okay, okay.
right hand
Ah,
side.
yeah, sorry. Ay. So I dot I is 1, I dot j is 0, j dot I is 0, j dot j is 1. So this one, I have to remember this. So we have to substitute these values in this equation. We get ax bx, I dot I is 1, ax by, I dot j is 0, ay bx is, so j dot I is 0, ay by, j dot j is 1. So we get ax bx plus ay by. So this is not needed. So we got a dot b as ax bx plus ay by, right? Ax bx plus ay by. So if you look at this, our result, you can see that first term is nothing but product of ax and bx, that is, okay, so we are multiplying x components, and second term is nothing but we are multiplying y components, right? So if you have one more term here, that is plus az, if you have one more term here, that is azk and b as bxi plus byj plus bzk, then a dot b is ax bx plus ay by plus, we have to write az into bz. Okay, so we are going to use this here. So let's say axi, so a vector is two I plus 3j minus k, b vector is 4I minus 8j plus 8k, right? So ax is 2, ay is 3, az is minus 1, bx is 4, by is minus 8, bz is 8. So if you substitute this in this formula, okay, so we get 2 into 4 plus 3 into minus 8 plus minus 1 into 8. So 2 into 4 is 8, 3 into minus 8 is minus 24, then minus 1 into 8 is minus 8. So minus 8 gets cancelled. We get our final answer as minus 24 joule. Anyone have doubts?
No, sir.
No, sir. No, sir.
Nice. Okay.
No, sir.
Excuse me, sir.
Yeah.
Sir, I can't understand the first sum, sir.
Which one?
First sum, sir.
This one.
Yes, sir.
So what is your doubt?
I can't understand, sir.
So look here. See here, what we have to find? We have to find work done by the gravitational force, right? So what is work done formula? Is gravitational force constant force or variable force?
Sir, I don't know about the
Constant force.
and variable.
Okay, look here. I'll teach constant and variable. Now look here. Constant means which doesn't change. Clear? Okay. Variable means it changes. So suppose when I write force value is 1 Newton, is it constant or variable?
Constant.
Constant. No, that girl. Hello?
Constant, sir.
Constant. Why is it constant? Because it's not changing. Is it clear? It is not becoming 2 Newton after some time, or it's not becoming 3 Newton after some time. Suppose I'll write force as F is equal to T. Is it constant or variable?
Variable, sir.
Variable.
Why variable?
Because it is being
See, when time t is equal to 0 seconds, what is the value of F? 0. Come on. Right? So when time t is 0, F value is
0.
Nice. So when time t is equal to 1, F value is
1.
when time t is equal to 2, F value is
2.
2. Wonderful. Now look here, I will call this force as F1, right? Now what is F1 value? 1 Newton. So when time t is equal to 0, what is F1 value?
1 Newton.
1 Newton. That girl, that girl. When time t is equal to 2 seconds, what is F1 value? No. See here. See, F value is, when t is equal to 1, F value is 1. What is F1? Very good. It's 1. When at time t is equal to 2 seconds, what is F1?
2n.
So why is see, F1?
1.
1n.
Yeah, 1 unit, right? Now when time t is equal to 3 seconds, F value?
3.
3.
Very good. F1?
1n.
1 unit. You can see that here force is not, no, which one is changing and which one is not changing?
F changing, F1 is not.
F
Okay.
changes and F1 is constant.
Yeah. So see, this is constant force. F is a variable force.
Wait.
So you can have different variable forces. Like look here, F is equal to T is a variable force. So F is equal to T square plus T is a variable or constant?
Variable.
Variable.
Variable force.
Wonderful. So F is equal to, V square plus S, where V is velocity, S is displacement. Is it constant or variable?
Variable.
Variable.
That girl. Nice. Right? See, and now in questions you might come across F is equal to A plus B, and they'll say A comma B are arbitrary constants. Clear? Arbitrary constant. So in this case, F is variable or constant?
Constant.
Very good.
Constant.
Why? Because A and B are
Constant.
Arbitrary constant.
very good. Nice done.
Arbitrary.
Okay. So that's why, see, so now can you tell me what is gravitational force in this case?
Constant force.
Constant.
It's constant. That girl.
Constant force.
Not okay, fine. See, gravitational force is constant force, and its value is how much?
9.8.
9.8.
Gravitational force. Wait, see, see, okay, 1 minute. There is difference between gravity and gravitational force. Okay, so gravity is
9.8.
yeah, it's 9.8. So gravity is acceleration. Is it clear? We call acceleration of due to gravity, right? It comes under acceleration. Then gravitational force is actually, gravity is a field. Gravitational force is force applied by the gravity.
Acting on some objects.
Yeah, correct. Yeah, right. Force applied by gravity on a body. So what is gravitational force on us?
9.8.
See, that's what I'm saying. 1 minute. Acceleration due to gravity is 9.8.
6.61 into 10 power minus 1.
9.8 meter per
Meter
second square.
per
See,
second.
9.8 is this thing, acceleration. Is it clear? Now, force applied by the gravity is, what is force
Mass
formula? Mass into acceleration.
Acceleration.
So, gravity, acceleration due to gravity is how much? 9.8, right?
9.8.
So, force applied by gravity is m into
9.8.
Gravitational.
So force applied by gravity on us is mass of our body into acceleration due to gravity. What is mass of our body into acceleration due to gravity? This is nothing
mg.
but
mg.
mg is
Force.
weight. Clear? What is mg? So weight of our body is nothing but mass of our body into acceleration due to gravity. Is it clear?
Yes, sir.
Yes,
sir.
sir.
Any doubts?
Yes, sir.
Nice. So what is force applied by body is nothing but force applied by gravity on a body is nothing but
Weight.
weight, right? Everyone?
Yes, sir.
Now look here. So what is gravitational force?
mg, sir.
Yeah, weight. Right? So gravitational force is weight. So weight is mg. So we have to find work. What we have to find here? Work done by
Gravitational force.
Gravitational force.
that girl. Let that girl say. What is her name? Hello, what is your name?
Naifa, sir.
Naifa. Okay, Naifa. See what we have to find here, Naifa. Yes, we have to find work done by gravitational force. So what is work done by the gravitational force? Gravitational force dot
Yes.
displacement. Is it clear? No. See, look here. Work done is F dot S. Work done by a force is F dot S. Since we are finding work done by a gravitational force, here the force is gravitational force, which is weight dot displacement. So here what is weight? So weight of, if this is a body M, weight of the body acts in downward direction, which is mg. So weight vector is magnitude mg into direction of the weight is downward. Okay.
Minus j cap.
Yeah. See, are you clear with directions, Naifa? Fine. Okay, you have to write minus j. So weight is minus mg j cap dot displacement is hj. Okay, if we do dot product, we get minus mgh. Okay. Next. So we have to do graph problems now. So they'll give graph. So they'll give a graph, force versus displacement graph. This is force versus displacement graphs. So area under force versus displacement graph is work done. The force versus displacement graph is work done by the
Constant force.
very good. No, actually it's work done by the force. Okay. Whether it's constant or variable, it's okay. Now look here. So the graph looks like this. So they'll give displacement on this side on x-axis, force on y-axis. So the graph, they'll give you some graph like this. Okay. So this is the area under the graph. Okay. This is the area under the graph. This area is the value of work done. Is it clear? So if they change this as, if they give this as S, this as F, then you should take this area. I have to take this area as, so this area is now our work done. Always remember that you have to find the area under the graph, and always, okay, you have to find area under the graph, in between the graph given curve and displacement axis. Always find the area between given curve and displacement axis. Okay. Displacement axis. Sorry. So question is, force, displacement, and the curve looks like this. So this is 1 unit, this is 2 units, this is 1, this is 2. See, this is force versus displacement graph. We have to find work done in this case. So what we have to do, we have to find,
Work done.
Work done.
yeah, very nice. We have to find work done. So what is work done in this case?
The effect or intercept.
See, area under the force versus displacement graph is
Work done.
work done by the force, right? So here we have to find the area under this curve. Okay. Sorry, this is not graph, this is curve. So see, this is our curve. Okay, this is straight line. So we have to find this area, right? So basically we have to find this area. Just take 2 minutes and give it a try. Yeah, just speak. So somebody raise his hand. Okay. So who raised the hand? Yeah, I think A. Tolkapian.
Sir, தெரியாம கைப்பட்டுச்சு சார்.
What?
தெரியாம கைப்பட்டுச்சு சார்.
Okay, fine. Now look here. See, here we have to find the area under the graph. So what we have to do here is, we have to draw a straight line here like this, right? So can you see rectangle here?
Yes, sir.
Yes, sir.
Yeah. There is a triangle here.
Yes, sir.
Nice. There is a triangle here, right? See, so here area under the curve is area of rectangle plus area of triangle, right? So what is the area of rectangle?
Length into breadth.
L into B.
Very good. So let's say this is length. This is
Sir, 3/2.
breadth, right? So what is breadth?
1.
Very good. It's 1 unit. What is length?
That's also 1, sir.
Very good. So area of rectangle is L into B, 1 into 1 plus area. What is area of triangle?
Half into B.
Half into B into
Very good. So what is B here?
1. That's also
H.
1, sir.
Everyone,
Sir, how's the breadth is 1?
look here. See, this is 2, right? Okay. See, this point is, what is this point? What is your name?
Hitesh, sir.
Hitesh. Okay. What is this point? Position of this point?
1, sir.
It's 0, 1. No, 1, 0, right? What is position of this point?
2, 0, sir.
Very good. So let's say there are 2 points, x1, y1 and x2, y2, right? So distance between these 2 points formula is between two points. I will call A point as x1, y1, B point as x2, y2. Okay. So distance between these 2 points is root of x2 minus x1 whole square plus y2 minus y1 whole square. Clear?
Yes, sir.
So what are the 2 points we have? So let's say this is 1, 0. This is
2, 0.
2, 0.
0. So what is x2?
2, sir.
2, sir.
x1?
1, sir.
1, sir.
1. What is y2?
0.
0. y1?
0.
Wonderful, wonderful. So what is 2 minus 1?
1, sir.
1, sir.
So what is root of 1 square?
1.
1.
1.
That's why we are writing 1 here. Okay. Nice
Okay,
job.
sir. Thank you, sir.
Nice. Okay. See, just keep asking doubts. Okay. Then you can develop yourself. Okay. So what is B? 1. Now here, what is H? Hitesh?
1, sir.
1, nice. We'll put 1 here, right? So what is area of now what is 1 into 1?
1.
1, sir.
1 plus 1 by 2. 3 by 2.
So 1 plus 1 by 2.
3
So what
by
is
2.
the answer? 3 by
3 by
2
by 2.
joule. Okay. Everyone clear?
Yes, sir.
Yes, sir.
Or you can write this 3 by 2 as 1.5 joule. Okay. Now I forgot simple thing. See here, we got work done as minus 24 joule, right?
Yes,
So
sir.
what is the angle between, what can be the angle between the force and displacement in this case?
0 degrees.
Sir, minus 180.
180 degree.
Look here.
180 degree.
See, we got minus 24 joule, right? So if you go back, see, if you come here, work done is negative in between. You take these two. See, angle can be in between. So we got minus 24, right? So since work done is minus 24 joule, negative, negative, right? So we don't know the exact angle, but the angle can be in between 90
90
degrees
to
and
180 degree.
no, 90 degrees and
270.
270 degrees.
270 degree.
okay, they can ask question like this. Just you have to, okay. We don't know the exact angle, but angle can be between 90 and 270. But how can we find angle between two vectors? How to find angle between two vectors?
Theta equal to cos inverse of
Very good. Theta is cos inverse of
mod of A, mod
A
of B,
dot B by
mod of A, mod of root of
right. Mod A into mod B by, so A dot B by mod A into
mod B.
that's it. Nice. You have to use this formula to find the angle between force and displacement here. Okay. Next. So this is area under the graph. Next concept is work done by variable force. So I hope everyone knows the difference between constant force and variable force, right?
Yes, sir.
Nice. Okay. So when the force is variable, that means force is a function of time. Force is given like this, or force is a function of displacement, or force is a function of velocity. Okay, we have to use this, okay, work done by variable force formula. So
Can you give example for constant force, sir?
so okay, fine, look here. So suppose, so what is your name?
Yugender, sir.
Yugender. What is your weight, Yugender? Let's say
45.
45 unit.
10 Newton.
Wonderful. Okay. Weight is 45 Newton. So as time goes on, does your weight change or not?
No, sir. It changes.
It changes. Okay. As time goes on, your weight changes. So is your weight constant or variable?
Variable.
Variable.
Is it clear? This is variable force, right? So your weight changes with time. Suppose I will say that my weight is not my weight. Suppose I will say that some force is 2t, right? So this is F. So at time t is equal to 0, what is the force value?
0, sir.
Again that.
0, sir.
Okay, you have to substitute t as 0 in this equation. You will get force as 0. At t is equal to 1,
2, sir.
2, sir.
2. At t is equal to 2,
4, sir.
4, sir.
suppose there is a force F1 which is 5 Newton, right? So at t is equal to 0 seconds, what is the force?
5 Newton.
5 Newton.
Okay, I will write F1 as F1 is 5 Newton, right? Can I write F1 as 5 into t power 0?
Yes, sir.
Right? Can I write it like this? Everyone?
Yes, sir.
Yes, sir.
Yeah. Why? Because
sir.
t power 0 is
1.
1.
now I'll substitute. Remove this. Okay. So if I substitute t as 0, what do I get? F1 as
5.
5.
5.
T if I substitute t as 1, I get
5.
sir.
if I substitute t is equal to 2, I'll get
5, sir.
wonderful. Now look here. If you look at these two forces, see this force is okay. Now, can you tell me, is the value of F1 changing?
No, sir.
No, sir.
No, sir.
No. So can I call it as constant?
Yes, sir.
Yes, sir.
Yes, sir.
Is the force value of force F changes or is it constant?
It changes, sir.
Changing, sir.
So it is a
Variable.
Variable.
okay. So this is variable force. So see, you have to figure out whether a force is variable or constant by putting values like this. Okay, if you are not sure, right? No. See. So F is equal to 2t is constant or variable?
Variable.
Variable.
Variable, right? So whenever there is a variable force, okay, you should not use this formula. Which one? Work done, okay? Never use this formula when the force is variable. You have to use this formula only when force is constant. So when you have a variable force, you have to write. Now, okay, 1 minute. So F is equal to 2x. Is it constant or variable?
Variable.
Variable.
So you have to use this formula. So what is it? Work done is equal to integral F dot ds, right? So what is F? F is
Force.
variable force.
Variable force.
What is ds?
Small displacement.
Displacement.
Okay. What is small displacement? Fine. So what is work done? F dot ds, right? So did you do integration problems in kinematics?
Yes, sir.
Yes, sir.
Variable acceleration problems. See, when acceleration is constant, you use these formulas, right? V is equal to u plus at, v square minus u square is equal to as. Then what is the other one? S is equal to ut plus half at square, right? Now, when acceleration is not constant or varying, what formulas you have to use? Anyone?
Sir, what, sir?
When acceleration is not constant or isn't constant or it's varying, what formulas you have to use? So see, you have to use S is equal to displacement is equal to integral u into dt, right? So then velocity is integral a into dt. Did you solve problems on this question? Okay, on these type of problems? Anyone
Yes,
else?
sir.
Did you solve problems on these concepts? S is equal to integral u into dt, v is equal to a into dt.
Yes, sir.
Okay, you solved it. Nice.
Sir,
Yeah.
sir, kinematics was not taught in the edutils, sir.
Oh, then fine. So
Last lesson was only laws of motion, sir. That also it is not fully completed, sir.
oh, it's not completed. Okay. Fine. Then this is hard. Okay, fine. So kinematics not done, right?
Yes, sir.
Fine. And laws of motion are also not completed. Okay. No problem. So I think maximum people didn't solve problems on integration, right?
Yes, sir.
So I won't touch this topic. So basically, see here in this work done by variable force concept, integration is involved. Clear? So so what is class timing? 7 to 8:30, right?
Yeah, yes, sir.
Yes, sir.
Yes, sir.
We'll stop it now.
Sir, can you show the three conditions?
Okay, 1 minute. I think I erased it. I don't know. So theta is equal to 0, 180. Which one? This one. This one? This one,
Yes, sir.
right? Okay, one
Yes,
minute.
sir.
Thank you guys
Thank you, sir.
Yes, sir.
Thank you, sir.
Thank you, sir.
for sitting
Thank you,
patiently
sir.
for 1.5 hours.
Thank you, sir.
Sir,
Thank you. Yeah.
sir, they started with only laws of motion, sir. Can you teach from first, sir? First lesson, sir. Can you teach from the first lesson itself, sir?
Yeah, I see. Okay, I'll let you know as soon as possible.
So please show the above diagram, sir.
Which one? This one.
Yes, sir. Yes, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you.
Sir, is various condition involves in determining
Huh.
a value is constant or variable. So,
See, I think I erased that. See, did you complete writing this?
Yes, sir.
This one? This one. Any doubts?
No, sir.
No, fine. Okay. Over this constant and variable.
So
Sir, F can be written as magnitude of force in the direction of displacement into
What? 1 minute. S can be written as.
as magnitude of force in the direction of displacement.
No, that
into-
is not F. That is F cos theta.
Okay, sir.
F cos theta is magnitude of force in the direction of displacement.
Displacement.
So
Yeah.
gravity differs from North Pole to equatorial, sir.
Yeah.
Is
Yeah,
it a constant or a variable?
no, yeah. See, for this chapter, okay, if they don't say anything about gravity in question, like if they say gravity changes, you have to solve, okay, the problem assuming that gravity changes. If they don't give anything in your question, you have to take gravity as constant. Yes, gravity changes. Okay, I think it's more at equator, lesser at poles. And it also changes with height. You learn this in gravitation. Okay, but for now you take gravity as constant. Clear?
Okay, sir.
Yeah. Is this over? So thank you. Have a nice day. Good night.
Thank you, sir.
Thank
Thank you.
you, sir.